Hi folks, Bart from bartb.ie here with a rather unusual installment or piece of content related to the Programming by Stealth series. This screencast is going to be embedded into Programming by Stealth 37. So the main reason I want to do this screencast today is to walk you through how to understand the documentation produced through JSDoc. I've given it as an input to the last two assignments where we've been working together on building our cellular automata prototype. And Alison pointed out to me that, I've given it to you as the documentation on the assumption that it's trivially easy to read and that it will just make sense to everyone. And that assumption isn't reasonable. That assumption doesn't actually make sense. It didn't occur to me that I was making that assumption because I've been doing programming and reading developer docs for 20 years. But 20 years ago, it wouldn't have made any sense to me. So why should it make any sense to, people who are starting on their programming journey now? Well, there's no reason it should. So I want to apologize for assuming that the documentation would just make sense. Dumb thing to do in hindsight. And so I want to sort of work through it from soup to nuts. So not just here's the finished product and here's how you interpret it, but actually here's the code, here's how it relates to documentation, here's how we turn that into the finished product, and here's how you interpret the finished product. And hopefully that will help everyone to understand the JSDoc documentation that I have included and will continue to include in various forums throughout this series. So this is not the first time we have encountered JSDoc. Way back in PBS 24, we sort of mentioned it briefly, and we went through some stuff together. So if you scroll way down through here, you do eventually get to the point where we talk about it. So we install JSDoc. So JSDoc is a JavaScript-based app to do documentation of JavaScript code. So it's a little bit self-referential. And as I say, it's all here in PBS 24. But I actually want to walk through it in a more practical way. And before I even do that, I actually want to do something else. I actually want to walk through sort of my tool chain to sort of show you how I go about, working on the code for these things. I'm not saying that you should all use the same toolset I do, but I think some of you may find it interesting to see what toolset it is that I actually do use, so I figure we'll start with that. Okay, so the first thing we need to do to work on code is actually get a copy of the code. Now, a lot of the time I will give you a download of the code to work from as a starting point to an assignment, but also a lot of the time we'll be working, all the code I produce as part of this series I tend to put up on GitHub. So I'm actually going to start the way I would start if I needed to, because actually at the moment the laptop I'm recording this screencast on doesn't have the code for our cellular automaton. So I'm going to go to github.com/BBUSSCHOTS. If I can spell my own name. And that will take you to my GitHub page. If you go to repositories, you'll see all of the code I'm publishing out, and Bartificer CAGS is the code for the cellular automata. Now, if you were logged into your own account, you would see something slightly different, but the important thing that you would still see is this button here, which is the fork button, which basically takes a copy of my open source code and plops it into your GitHub account. And once it's in your GitHub account, you can then check it out and alter it and edit it, and then you have your own version tracking of it. You can also pull in changes I make into your copy later if you want to, and you could even suggest improvements to me with a pull request asking me to pull changes back from you. Not guaranteeing I'll accept your changes, but, if you have something to contribute, I'll consider them. So once you have the code in your GitHub repository, how do you get it onto your computer? Well, you could clone or download. Download a zip file, that's what it says in the tin. Or here is the URL to actually use the git terminal command to pull down the code. But the easiest way is to actually use the Github Desktop App. So it's a free app released by actual GitHub. So I always have that app open. So at the moment, the only code I have checked out on this computer is HSXKPassWD, which is my open source project. So if I wanted to actually get the cellular automata code, I would go plus clone, And that's all of my repositories. So if you do that, it'll be all the repositories in your account. So we are looking for artificerca.js. We will clone it, please. I have a very magically named folder called From GitHub, where I download all of my GitHub stuff, so that'll do fine. Clone. Cloning. There we go. All the code is now downloaded, and you can see a snapshot of every version of the code showing all the file changes and everything. But really the more interesting view is whether or not you have any changes since your last commit, so no uncommitted changes. So if I pop open a Finder window, my From GitHub folder, artificer.ca.js, and here we have the code, which looks pretty much exactly as it looked when it came down from when you guys would have downloaded a zip file, because in fact what I do is I take this folder and I zip it up when I upload it, and that's where that zip file comes from. So the first tool in my toolkit is GitHub. Now you can get a GitHub account for free. It limits some things you can do. It forces you to use open source licenses for things, and it doesn't. I think it allows you a limited number of private repositories. I have the cheapest tier paid account because I keep some private repositories. But it's a fantastic free service, which has affordable plans if you need more features. And they have the free desktop app, so you don't even have to spend too much of your time learning the somewhat tricky terminal commands for Git. So that's the first tool on my tool chain. And so now I want to teach you about something else. Okay, so we have our code safely downloaded. Great. We probably want to edit said code. So in order to do that, we're going to need some sort of coding editor. And I use lots and lots of different editors. And every month or two, I seem to change my mind. When working on actual HTML, I quite like Code Runner because it lets me sort of have a browser window within the editor. But when I'm working on more hardcore APIs, I actually prefer to take out a sort of a bigger sledgehammer, a bigger tool, which is an IDE called Komodo Edit. And it is currently on Komodo Edit 10. Now, Komodo Edit 10 is free and open source. It is a stripped down version of a very not free, very high level IDE called Komodo IDE. If you're going to look for Komodo Edit, they're going to try to sell you Komodo IDE. Just be careful where you click and you will get the free Komodo Edit, and it's a fantastic app and I love it very much. But don't think what you're seeing here is the many hundreds of dollars Komodo IDE. This is the free and open source Komodo Edit. So since I've just downloaded this code from scratch, I actually need to start by creating a new project. So we say new project. I could browse, but I'm a lazy sod, so I'm just going to drag and drop. There we go. So we're now in the folder, and I'm going to name my project very imaginatively. artificer.ca.js.komodo project. Save. Okay. So here's the folder, which has our source file in lib, artificer.ca.js. So we can open that up. And that is the full source file. All 900 lines of it where it stands. In fact, I've done your homework for the next installment, so yours may not have quite as much in it. Anyway, here is a snapshot of the code as it currently stands. So the next piece in the toolchain I want to talk to you about is documentation. Programmers don't know functions. They don't know what arguments are expected. They don't know these things. What they have is the skills to quickly and efficiently look them up. And you can use a web browser for that, and you end up with a browser with many tabs, and it is perfectly viable. But it drives me up the wall because I tend to have lots and lots of browser windows with lots and lots of things, and what I actually want is something I can command tab to that's only for my documentation, where I can keep bookmarks and notes and snippets of code and stuff all together in one easy to get to app. And the solution to that is a non-free but not horrifically expensive piece of software called Dash. So let's see where that is. So it's called Dash, and it's a Mac OS app. So if we search for Dash Mac OS, there we go. So capelli.com/dash. And as you can see, the price is $24.99. Now, this is my Mac, so of course Dash is already installed, so I actually don't need to do that. I can just bring up Dash. Now, Dash works off the idea that you download sets of documentation which you can then easily search within this interface. So I have preloaded this with the relevant documentation sets for what I'm currently using this Mac for. So I have the documentation for JSDoc here. So I have a reference to any tag. How does the enum tag work? That's how the enum tag works, right? So it's also, they tend to be broken into, they're all laid out differently, but basically you can see how the command line works, all this kind of stuff. So there's the documentation for JSDoc. I have the documentation for jQuery here. Ajax, right? Everything that we're used to seeing is all here. I have the stuff for Moment.js, which is the library we used when we were doing our clocks example quite a while back. Bootstrap, that's a little view into the future actually, but we will be talking about Bootstrap at some stage in this series because Bootstrap rocks. And then of course we have the core JavaScript documentation, and I can search within it. So if I want to know how JavaScript date works, okay, there's the date class. Gives me some idea of the syntax. I can bookmark things, etc. It's a particularly nice way of dealing with documentation, I find, and it is a tabbed interface, so I tend to have a tab open for every technology I'm using, and I can quickly search. I think it's worth the $25 basically. So that's the next tool in my toolkit is Dash. Okay, so now that we've seen my tool chain, let's get stuck into the real meat and potatoes here for today, which is looking at JSDoc comment style documentation. So what I'm actually going to do is walk through documenting a specific function. The function I have chosen is the function bartificer.ca.automaton.prototype.cellState. In other words, this function is to give you the state of any given cell within an automaton at any given time. So basically, what state is cell 4,2 in is what this function is for. So I've copied and pasted the code out of my main editor into Smultron here, just so it's a little easier to see, and so you don't see the doc comment until we build it up together. So here's the entire code of the function. It's 12 lines long. It's not a particularly exciting function. The function's name is cellState. It belongs to the bartificer.ca.automaton prototype, as you can see by its name. It takes two arguments, which we're calling x and y, which you can see at the end of line 1. And clearly it throws errors, and it has a return at the bottom. So if x or y are in some way invalid, it throws a type error. If x is somehow out of range, so if your automaton is 10 cells across and you ask it for cell number 15, that's obviously not appropriate. I mean, 15 is a conceivably viable x coordinate. It's just that in this particular automaton, if it were 10 across, 15 would be nonsense. So if that happens, we throw a range error, and we do the same on the rows. And if all of that succeeds, we simply go to our grid, go to coordinate x and y, and use the state accessor method on the cell object, and we return that. So return this underscore grid xy.state. So it's a very simple function. Now, when it comes to documenting what a function does, it's always about three pieces of information. The developer using your API wants to know three things about your function. Your function should effectively be a black box. They shouldn't need to know how it works. What they should know is, I guess, three quantitative pieces of information and a qualitative piece. And the qualitative piece is basically an English description, which basically says what it is this function does. A lot of the time, that's actually not that important. You generally won't read that from the documentation so much as usually, most of the time, the name of the function is sufficient. And in fact, the better you are at naming your functions, the more it is that simply looking at the name will be sufficient to figure out what the function does. But nonetheless, there is a need for an English description, which is sort of qualitative. It's fuzzy. But there are non-fuzzy factual pieces of information that the developer wants if they're going to be using your API. So if you treat a function as a black box, then the first thing it does is it takes some inputs, does something to them, and produces some outputs. So which arguments or parameters, arguments and parameters are synonyms, what arguments does the function expect? What are they, and what values are valid, what values are invalid, which arguments are required, which arguments are optional, all that kind of information. That's vital. So that's the inputs to your black box. And your black box will do something, and it will probably produce some outputs. It may not if it's a void function, but a lot of functions produce an output. And if it doesn't produce an output, that's also a factual piece of information. So you then want to know what's going to come out of this box. What data type is it going to be? What range of values is it going to have? So that you, as a developer, know what to do with the output of this black box. The other thing that can happen inside this black box that can come out and, I won't say bite you, but basically that can interact with the code of the person using your API, is that the black box, i.e. the function, can throw errors. And so you should tell the user of your API up front what possible errors might be thrown and why. And that way the user of your API can catch them in a sane and sensible way. So it's about what goes in, what comes out, what can be thrown, and some English descriptions to tie it all together. That's what we want to capture in the doc comments, and that's what will be available to us in the resulting documentation. So here we have the code with absolutely no comment yet. So as a refresher, you start a JSDoc comment with /**. So the second star trip is basically saying, and I'm a JSDoc comment. It's a multi-line comment, so we can continue as long as we like. And then we end it with just //. So the first thing you put in your JSDoc comment is your bit of English. So a function for accessing the state of a given automaton cell, something like that. Right? You may vary a bit, but you're going to give it some piece of English. In fact, here's one I prepared earlier, marginally different, but basically the same. A function for accessing the current state of a given cell within the automaton. Okay, so that deals with the first part of our requirements. There's a little bit of English. Next thing is, what inputs does this black box, this function expect? So you define an input using what's called a tag in JSDoc. So the Englishy bit is kind of free form, and now we're going to use a formal tag. So remember, JSDoc is in itself like another programming language. And tags begin with the @ symbol, and there are all sorts of them defined. So if I quickly flick over to dash here, and I expand out my JSDoc, you'll see that it lists all the tags in alphabetical order. And the tag we're interested in to describe the inputs to a function. So in this series, we tend to use the word arguments. Arguments is a synonym for parameters. So some people use arguments, some people use parameters. The authors of JSDoc went with parameters. So the tag we're looking for, HIJKLMNOP, param, which does have synonyms at argument and at arg, but I tend not to use synonyms in my JSDoc comments because that just confuses other developers. So I tend to use the official tag rather than a synonym. I guess if you feel very strongly about using the word argument, you can use at argument instead of at param. I'm going to use at param. And so the document describes what it does, but I actually find with the documentation from the JSDoc project, I just scroll straight to the examples. So name, type, and description. That's kind of what we want. So at param, type in squiggly brackets, name followed by description. And in actual fact, I prefer this form. So you can have a minus sign after the name, so it's obvious that the first word is not actually part of the sentence. The first word is the name of the argument or the parameter, and then the sentence begins. So I like the minus form. Basically, the two examples on screen here are actually, they will have the same output, but I find the second one clearer, so that's the format I use. So let's flick back to our code. So first parameter is x, so at param, some sort of type. We'll come back to that in a minute, and it's going to be called x. The x can't spell, ordinate of the cell. something simple like that. So what is the type? Well, within JSDoc, types always fall into one of three categories by definition. So a type is, at its simplest level, it can be a native JavaScript type. So in other words, something that can be returned from the type of command. So that means Boolean, that means string, that means number, that means object, and that means function. So those, and they all start with a lowercase letter because that's how they come out of the type of operator. So they're native JavaScript types, and you can put them in here. So if x were to be a number, we could just say number. And actually, as a first approximation of what we're doing, that's actually not a bad approximation because the x-coordinate is a number. But that's very general. So if you're doing a first draft documentation, that's actually acceptable. But when we say a coordinate, we actually mean something much more specific. We mean a number, that's a whole number, so an integer. And for it to be a valid coordinate within our coordinate system, it actually needs to be greater than or equal to 0. Because our x-axis starts at 0 and counts up from there, and it can go as big as your automaton. So what we really want here is not just any old number. What we want here is a number with some extra caveats, some extra description, and basically it's a number plus some English is what we want to convey to people. And the way you convey that to people in JSDoc is that you create your own custom type, which is something using something called a type def. So that's actually what we're going to need to do here, but I'm not going to do it just now because I also want to tell you about the third type of thing. So you can have a built-in JavaScript type. You can have the name of a prototype, or you can have one of these self-defined data types. And so you define a data type using the typedef tag, and you don't define the data type within the comment for the function you're commenting. You actually define a typedef in a completely standalone comment. It's basically a little bit of English at typedef, then inside squiggly brackets, the type information that this type sort of extends, and then a name for the type. So in the example here, the typedef is number-like, and it can be a number or a string. A number or a string containing a number. So that's the English first. And something number-like is a number or a string containing a number. And then it can, strictly speaking, be either a number or a string. So within a typedef, you can do or with the vertical pipe, and you wrap everything inside roundy brackets. So that's a nice example there. And then you give it a name, number-like. So then you can see below that if you want to define a parameter, you say param number-like x. And then when you create the finished documentation, there will actually be a link that will take you straight to the English for what it means to be number-like. So in our case, what is x? Well, x is a coordinate of some sort. So we need to define a type for a grid coordinate. So if you look at the original code, you'll find that there is a typedef for grid coordinate. So we have here a number representing an x or y coordinate within a cellular automaton. So we have a typedef for a grid coordinate, which is a special type of number, and it's called grid coordinate capital G, capital C. So we should copy this, and we should use this here. So it's not a number. It's a grid coordinate. So it's more specific. We're going to do something awfully similar for y, because it's also a grid coordinate, the y coordinate of the cell. So we've now defined our two inputs. So again, what I did when I did it properly was marginally different. So here things stand now. So we've now defined our vague fuzzy English. We've defined what goes in. So the next thing is what comes out. And the way you specify what comes out is with the @returns tag. So if we click up here, we say returns. It has a synonym for @return, which I think is a synonym there mainly for the purpose of avoiding annoying typos causing bugs. I do my best to always use the plural, but every now and then in my own code I find @return instead of @return, so I guess it's a useful synonym. Anyway, it's basically @returns, and you say returns a type in squiggly brackets followed by some English. And in this case, very, very annoyingly, it's not a minus sign. It's just straight into the English. So let's go back to our code. So we say we're going to return returns some type and then some English. So the state of the requested cell is what's coming back. So what type will that be? Well, we actually again have a type def for that. So if we go back and we look here, we have, if I do a command F for cell. So we have a type def, a valid cell state, a boolean, a number, or a string. At type def, boolean, or number, or string, cell state, capital C, capital S. So let's copy that because that's actually what's going to get returned from this function. So at returns a cell state, the state of the requested cell. Okay, or in this case, what I actually had originally was the current state of the cell at the given coordinates. Okay, so we now have our fuzzy English, what goes in, what comes out. So the other thing I said is very important is what possible things can be thrown here, what errors can get thrown out. And so for that, we have another tag, which is at throws. So let's go and have a look in dash at what at throws does. Throws. So you can either have just a freeform description, you can have just a type, or you can have a type and a freeform description. And in this case, the type is going to be the prototype of the error you're going to throw. So if you look at the code here, we throw two possible errors. We have type errors if someone gives us absolute garbage, and we have range errors if someone gives us a plausibly valid value that's just too big. So that means if you throw two types of error, you should have two throws statements. So first throws, the type, the first thing that can come out is a type error. So at throws type error. A type error is thrown when either argument is invalid. Seems at least a plausible way of describing it. Throws, and then we do something similar for range error. A range error is thrown if either the X or Y coordinate are beyond the edge of the automaton, or something like that. Let's see what I actually wrote when I did it for real. Okay, a range error is thrown if either the coordinates specify a cell whose coordinates are beyond the edges of the automaton. So that is our doc comment. Now, writing it is actually, if I was doing this entirely for real, I almost always write the doc comment before I write my code, because it makes me stop and think, well, what is this function for? What's its role in life? And so I'll document it first, and then I'll write the code. And the other thing I find is that the tests that I write in my test suite are extremely heavily influenced by this comment, because this comment tells me what is valid input, so I need to check that everything else is invalid. It tells me what arguments are optional or not. I should show you that actually. So if we were to decide, and it makes no sense, but hypothetically, if I wanted to make Y optional, I would say Y in square brackets. And if my code gave Y a default value if you left it blank, then I could indicate that by saying Y equals 5, say. And that basically means that Y is optional, and if you don't give it, I'll make it be 5. So it's actually quite useful in that way, but in this case, all of our arguments are required, so let's do that. So the tests I write are very heavily influenced by my doc comments, particularly, so, okay, how do I validate that? How do I test that the argument is that the function is validating its arguments correctly? Well, I read what the arguments should be, and then I write tests to make sure that if I do give it those arguments, I don't get an error, and if I give it something else, I do get an error. The other thing it tells me is what should come out of the function, what the return value should be. So if the return value doesn't meet the criteria I say it should, then my test should fail. And then the throws helps me write my tests for testing the parameters as the arguments, because it tells me what type of error should be thrown if there is something wrong with the arguments. And B, it tells me what other errors to test for. So it tells me that I need to test for range errors and for type errors. So again, that's all useful stuff when I'm writing my tests. So it all I'm hoping you see that it all sorts of hangs together. What you write simultaneously effectively on a per function level is you write the documentation for the function, you write the function itself, and you write the unit test. And you do those three things on a function, and then you move on to the next function, and then you move on to the next function. And so you build up your code in little chunks of code, documentation, and tests. And then you move on and do some more code, documentation, and tests. So you don't do all of the code, and then all of the tests, and then all of the documentation. That will just drive you absolutely mad. You build up all three. So they're basically three pillars of the stool of good software, and you build them up in line with each other so that your stool is never too wobbly. Okay, so it's all good and well to see how we write the doc comments, and it'll take you a little bit of practice. So the next thing we need to do is turn these comments in our code into a nice HTML page that is actual documentation. And so within the code, you can already get a lot of value from this because you can read a lot from here, but you have to do a lot of scrolling around. So if I go to the real code file here, and we go right to where our function is. So this is our example function in context. And I'm reading the comment and go, oh, great, grid coordinate. What was grid coordinate? Okay, so I'm going to have to scroll all the way up to, I'll scroll all the way up to find out what a grid coordinate is. Blah, blah, blah. Where is it? Oh, here it is. Okay, and then you're scrolling up and down and up and down and up and down. Because, of course, writing the comments isn't really the way that you're expecting to read the comments. The way you're expecting to read the comments is in a web page, and the joy of a web page is that it's hypertext, which means things link to each other. So I don't have to go scrolling around to find out what the cell state is. I can click on it because it's all linked together. So how do we turn this into a nice web page? Okay, so the key to generating our JSDoc web page is the JSDoc command, which is actually written in JavaScript. And we get it onto our Macs or Windows or Linux PCs using Node.js, which is Node.js is basically a JavaScript engine for the command line and other things. So if you haven't played around with Node.js, we've mentioned it quite a few times now in the PBS series. You can go to nodejs.org. So you can download here either the long-term release, the LTS release, or you can get the latest, greatest, coolest features with the current release. Both are fine. The LTS will give you long-term support. You won't have to change your version number very often. The latest, greatest, cutting-edge features gives you lots of cool stuff. And to be honest, most of the things we're going to be doing in fact, everything we're doing in Programming by Stealth is aimed at the long-term support. We're not doing any of the cutting-edge stuff. We're not using ECMA script 2015. So that means we don't need the version 8. So version 6, absolutely fine. And it's nice and stable and good. Anyway, download, install it, very easy to get. And then you end up with a command line tool, which allows you to run JavaScript. And that tool comes with a second excruciatingly useful bonus extra, which is something called Npm, the Node Package Manager. And it allows you to install JavaScript APIs and packages and libraries and things like that. Modules is the Nodey name for them, from other people. And there's a central repository of them, so you just basically npm search what you're looking for. There it is, npm install name of package. So first thing is, if we look at the files for our project, you will see there is a file called package.json. And package.json is something the Node Package Manager looks at to understand what's going on. So Artificer CI.js doesn't need Node to be used, but we do use Node in the development process. So package.json allows us to specify to the Node Package Manager what we need. So if I open that file in my code editor here, so if I go to package.json here, you'll see that, as its name suggests, it's a JSON file. And it defines a whole bunch of things: name of the package, version number, description, blah, blah, blah. But the other important thing it defines is the developer dependencies, dev dependencies. And what we need is JSDoc, version 3.4.3 or higher, and something called Minami, version 1.1.1 or higher. Minami is a JSDoc theme. So we're going to use the Minami theme with the JSDoc command. So those are the two dev dependencies. So this file will tell the Node Package Manager what we need. So if we open a terminal now in that folder, and it's important we go to that folder, so we go cd space, and because I'm much too lazy to type, I'm going to drag and drop from the proxy icon. There we go. So I'm now in that folder, so I can see all the files there. There's my package.json. So all I have to do now is tell Node to install what I need. So I just go npm install. I don't have to do anything else. Node will know everything I need. It will figure it out. There we go. So Node says install the whole bunch of packages. And it will create a new folder called node_modules. And if we expand that out, we'll see that it contains a whole bunch of stuff, including JSDoc. So basically, this is JSDoc and Minami and all of their requirements. So these are other packages required by those two packages we actually specified. So it's gone and fetched all the prerequisites and built it all together into one tree. So there we are, our node modules. So that means we can now use the JSDoc command. Now we could type it out every time, but what I like to do is use a configuration file so that I don't have to remember all the options all the time. So there's another file you'll find sitting here, which is JSDoc.conf or .conf.json. This is another JSON file. So this is the configuration for JSDoc. So the first thing is you specify what JavaScript files you want to document. In other words, what files should be included. In the case of our API, it's just one file. So we just include ./lib.bartfisser.ca.js. Opts allows us to specify command line options in this file. So we're saying destination./docs. I want you to write the web page you create to a folder named docs in the current directory. And the template I would like you to use is inside node modules Minami. Templates then allows you to specify some options for the template. So default are sort of options that you give to all themes, and then sometimes you need to, some themes look for options in slightly different places. So to make this more robust, the use long names in nav option is in two places. I just find it works better that way. And output source files is false. You could go with all the default settings if you liked. And then the last thing is there's a concept of plugins within Node.js, or sorry, not within Node.js, within JSDoc. And the only plugin I make use of is Markdown. So Markdown allows us to use Markdown syntax within the Englishy bits of our JSDoc comments. And that can actually be extremely useful for things like lists. In fact, there's an example because we say that a cell state can be, or was it? We say the container can be one of a few types. So if I look for container, jQuery single container. Okay, that's not the one I've done it on. Well, somewhere in this code there is a list. Let me see if I look for star space star. Oops. Yeah. Okay, we're doing stuff italicizing. Anyway, I digress. You can use Markdown. So here's the backticks used to make code tags. That's actually excruciatingly useful, is to be able to do code tags by just having backtick, whatever you want, backtick. So, oops. Here's our configuration again. So we're saying we're allowing Markdown. I want you to take that file, turn it into documentation, put it there with that theme and a few options. So we could manually type the JSDoc command. But if we go back to package.json, there's another interesting thing here called scripts within our package.json. And this allows us to define some scripts that we can just run by name. And the important one is generate -docs. We'll come back to generate -docs -dev in a moment. So for now, let's just look at generate -docs. And generate -docs is actually the JSDoc command. So we're saying get JSDoc from node modules bin JSDoc -- configure and then our file. In other words, run this version of JSDoc with this configuration. And so when we want to generate our documentation, we would simply go to our terminal. We have to be in the right folder, so we have to be in the same folder as our package.json file, and then we can say npm run. So run is the magic word for execute a script, and then we give it the name of the script. Generate -docs. Boom. Done. So it has now generated a fresh copy of the documentation. So let's look at that. A fantastic terminal command. We did talk about it on the Taming the Terminal series, but we haven't talked about it here in Programming Myself, is the open command. So we say open what you want to open. So docs/index.html, and then -a for the app you want. /application Safari, please. And there we are. It's open in Safari. So this takes us to the home page of the documentation. And an awful lot of this is auto-generated, obviously. And the home page is a description of the file as a whole, which is why it says bartofficer.ca.js. And it says, a JavaScript API for creating cellular automata. This API is entirely contained within the namespace bartofficer.ca, which is a clickable link. So that immediately tells you that if you're done reading this boilerplate stuff, what actually matters is click in here and you go straight to bartofficer.ca. But let's not do that. So, to be honest, the most powerful thing on this page is actually the sidebar. So this sidebar here gives us a great overview of everything. So getting to understand the sidebar is actually the single most important thing you can do. So let's look at the sidebar. Okay, home. That's very straightforward. Classes. Now, this is somewhat annoying. A class is a synonym-ish for a prototype. In what JavaScript does with prototypes, other programming languages do with classes. And JSDoc it wasn't originally dreamt up for JavaScript. JSDoc is a tweak of something, of a language developed for documenting Java code. And Java is, of course, all class-driven. So, unfortunately, JSDoc has taken some Java words sometimes where it probably shouldn't. And one of those is it likes to talk about classes instead of prototypes. So class is a synonym for prototype. Not strictly true, but effectively true. And it's because it's JSDoc running home to its JavaDoc roots. So the classes is going to define our prototypes. Now, we see bartofficer.ca.automaton. I recognize that. That's a prototype we wrote together. And I recognize bartofficer.ca.cell. I recognize that as a prototype. What's all this other stuff? Well, this other stuff, look at it as a sub-menu underneath the class. So if it has a pink C at the front of it, or purple, I'm a bit colorblind, I'm not sure what color that is, then it's a class, which we should in our brain think of a prototype. And if it has an F in front of it, it's a function. So in other words, $container is a function provided by the class bartofficer.ca.automaton, or the prototype bartofficer.ca.automaton. So in other words, these are the functions that exist within the prototype, and these are the functions that exist within the cell prototype. So for anything object-oriented that we do together, any APIs we build, the classes section of the sidebar is by far the most important, because it really does show the structure of our code. We have two prototypes which contain a bunch of functions. Next down then we have something called externals, which may not exist yet in the version of the documentation that I gave out at the end of PBS 36. Externals are exactly like type defs, but they describe stuff that is outside of your code. Your code is using something that came from outside of your code. It is external to your code. And so there is one external defined here, which is jQuery. A jQuery object. C, a link. Not entirely exciting. But wherever I use a jQuery object, I can say it's an external jQuery. And then I have a link here to anyone who wants to go read up the jQuery API. So it is slightly useful. And I guess I could have put a longer description if I wanted to. But anyway. So that's externals. Namespaces, well, as his name suggests, namespaces are namespaces. They begin with an N in the sidebar, externals with an E. So the Bartofficer namespace contains, the CA namespace contains all of our stuff. So they both exist in here. So if I click on Bartofficer, it says the global namespace used by Bartofficer creations when publishing JavaScript APIs. It contains namespaces, just CA. So I can click CA to go into the bartofficer.ca namespace, or I can get to it in the sidebar, because the sidebar is useful. Bartofficer.ca, a JavaScript API for creating cellular automata within HTML documents. This API uses jQuery to interact with the DOM, so jQuery must be loaded into the browser before loading this API. Link to jQuery. The Bartofficer.ca then contains two classes, automaton and cell. so we can navigate around here if we weren't to use the sidebar. And then finally we have globals. So these are things that exist globally within our code. And the globals are our type definitions. Cell state, a valid cell state, a boolean or a number. Type, boolean or number or string. Grid coordinate. Now again, I don't like the typography here because this doesn't, the type doesn't look to be particularly less important than cell state, but it is. It's a subheading of cell state. So really cell state is a heading, grid coordinate is a heading, grid dimension is a heading, initialization function is a heading because that's a description of a callback. jQuery single container is a heading, and down we go. So if we link to some sort of type def, we'll get jumped to the globals page, and then we'll get jumped to the right to a certain point within the globals page. Okay, so let's now look at our two prototypes, bartificer.ca.automaton and bartificer.ca.cell. Doesn't really matter which I pick, but let's pick cell since we wrote that one first. So this is a top level link, and these links are actually links to anchors within the page. So if I click on bartificer.ca.cell, it gives me a sort of an overview. First it starts off with, so whenever you see this, new, and then the name of a class, what it's telling you is this is how the constructor works. So the keyword new tells you you're seeing the documentation for the constructor. Then it says that it expects 1, 2, 3 arguments, and then the fourth argument has the letters opt written after it. In other words, the fourth argument is optional. We then have our fuzzy English, and then it says what parameters the constructor wants. So it says the name, the type, attributes are basically things like optionalness, and then a description, which is the more fuzzy English. So let's actually jump to the function that we looked at, which was cell state. Let's jump to cell state. So here's the heading at the top of cell state. It says cell state takes 2 arguments, x and y, and then this arrow here means, and it produces a cell state as its output. In other words, it returns a cell state. If you remember back to our doc comment, which I can jump you through so you don't have to remember back, we have our fuzzy English. And here's our fuzzy English. Then we have our @param statements giving us, our tags, giving us the list of what arguments are taken. Here they are, now represented as a nice table. And I mentioned that grid coordinate was a type def. Well, now I don't have to go scrolling looking for it. I can click, what is a grid coordinate? A number representing an x or y coordinate within a cellular automaton, specifically an integer number greater than or equal to 0 type number. So there we have it. The next thing in our comment, we have the returns. Now the returns is down slightly lower, type cell state, again a clickable link, and then our English. And what you'll notice is that the stuff we really care about is actually already up here for us to see, just straight in the heading. And then we also have our throws statements. They're in a bulleted list, 1 for each @throws. So we have our type and we have our English. So that is how this maps onto this. Now, again, the thing to notice is it's one HTML page for the whole of bartificer.ca.automaton, which I scroll through. I first get the constructor, which we know is a constructor because it says new. And as I scroll through, I get to a heading that says methods. Methods is a synonym for functions. So then we have $container, $table, cell state. That was the one we just looked at. Calls, dimensions, render function, rows, all of these. So this is a page, these are subsections within a page. This is a page, these are subsections within a page. This is a page, this is a page, this is a page, and this is a page. So I hope that makes some sort of sense. Now, this is the public documentation. So this documentation is written with a target audience in mind of another programmer using your API. They have gone, you've written the API, you've published it somehow as open source, and someone who's not you is using that API. They have no idea how it works on the inside. They just want to use it to do something, and they don't want to need to know how it works. So this documentation allows them to see what prototypes exist, what their constructor expects as arguments, an English description of what they do, and the various functions available, and what inputs there are to those functions, what output those functions produce, and what errors those functions throw. In other words, everything that a user of your API would want to know is here in this user documentation. So that's the user documentation. Now, what's this developer documentation I mentioned a few times? Well, the developer documentation has a different target audience. The target audience for the developer documentation is for someone who's working on creating, modifying, maintaining, extending, basically someone who's altering the code for the API. It's aimed at us, the developers of the API. So that could be if you're working alone on a project, the target audience for the developer document is a target audience of one. It's you. But that still makes it extremely useful because you will often need to look things up. If you're working within a team, the target audience is your team. That's also important. And in fact, in a team, it's extra important that you have good documentation. So what makes developer documentation different from public documentation? Well, people using your API not only don't need to know how it works on the inside, they don't want to know. The whole point of using someone else's API, of not reinventing the wheel, is that you don't care how the wheel works. You're interested in the presented functionality. But when you're developing, altering, maintaining, improving an existing API or writing an API, you do care about the innards. You want to know how the innards work, and you want to be able to quickly check how some internal feature works. So the difference is that it shows you the insides. And the way you tell JSDoc whether something is public is basically as part of the normal documentation or if it's part of the special developer documentation is that if it's part of the developer documentation, you give it the tag @private. So @private means this is only the developer documentation. So in the public facing documentation, we really did focus on prototypes and functions. But in the developer docs, you also care about the data stored inside your prototypes. And so you document that too. So here's an example of this $container. So we just give it /*, so it's a JSDoc comment. We give it some English, a jQuery object representing the container for the automaton, @private. In other words, this is only for the developer documentation. And then we have to say, well, what type is this property? So we use a tag we haven't seen before, which is the @type tag, which simply takes a type definition in squiggly brackets. So I now know that this $container is a jQuery single container. Again, that's a type def, which will be a clickable link within the generated documentation. We know it's private, and it has jQuery has an English description. So let's generate our developer docs so we can see what they look like. So again, if we look in package.json, we'll see there's already a defined script called generate docs -dev. And it calls the same binary file, and it passes the same configuration file, but then it gives two extra arguments. --private means include the private stuff. --, destination docs-dev. In other words, I'm overriding the destination specified inside the config file, which has to put in a folder named docs, and saying, no, I want this particular documentation in docs-dev. So if we go back to our terminal and we run two commands up, generate docs -dev, boom, churn, a new folder has been created called docs-dev. So we can again open the file. So this time we want to open docs -devs index.html. So very first glances, if you go home, not altogether different. In fact, shockingly similar. But as we dig into things, we do start to see differences. So if I go here and just click into the automaton, we can see this is what we've seen before. So we go straight from, here's the constructor, here are our methods, and that's it. That's where the documentation ends. If I go in here, first off, we have a bunch of extra stuff in that sidebar we haven't seen before. Come back to that in a moment. And if I go into ca.automaton, we have our constructor just like before. Takes our parameters, takes our throws, and then we have a new heading we haven't seen before, members. This is describing all of the data. So this $container, The this bit isn't shown, it's just the $_ container is what becomes a heading. So the first thing we get is some information private. In other words, you are looking at something that is not visible in the public documentation. : jQuery single container. In other words, this $_ container is of type jQuery single container. Again, it's a type def and it's clickable, so it'll take me to the type def. And it tells me the type again, it gives me the English description. Next one, $_table, English description, type, and the summary. _calls is a grid dimension. Private is an arrays of Bartificer CA cells. So array. So array dot is an array of. So array dot arrays of Bartificer CA cell. 2D array of Bartificer CA cell objects representing the cells in the automaton. Again, continue on. Then we get to our methods, which is the same stuff we've seen before. So the developer docs are a superset. Everything that's in the regular docs is in the developer docs, as well as all the stuff marked as @private. So what then are these guys here? Is cell state. Well, within the Bartificer.ca namespace, there's a whole bunch of private inner functions. So inner means they're defined within the namespace. So it's a function inside a function, because our namespace is a self-executing anonymous function. So private inner. In other words, this function is only actually available inside. The function doesn't exist outside of the JavaScript file because of closure. So it's actually trapped inside that self-executing anonymous function. Its scope is confined to actually inside. So this is useless to anyone who's using our API, because they're never writing code inside our API. So inner stuff really is only of use to people working on the actual, creating the actual API. So private and inner is cell state. Arrow, Boolean. In other words, one argument named S and it returns a Boolean. S can be of any type, the value to test. Test if a given value is a valid cell state, a Boolean, number, or string. Oh, that @c tag is wrong. I'll have to fix that. So this is showing us basically everything we've seen before plus the extra bits. So say automaton now has a whole new section named members, and CA cell has a whole new section named members. Other than that, it's all the same as what we've seen before. So I hope, having seen the JSDoc from soup to nuts, I hope that's helped understand what it's about and why it exists and what information you can suck from it and how you can suck the information from it. I'll be interested in your feedback on this. Maybe it's taken me 20 years to get to the stage where I just slurp up this kind of documentation. This is what I want to see. If someone gives me some code they want me to use, I don't want an English description. What I want is this kind of highly structured documentation, and I want it produced by some sort of standard tool. And for JavaScript, the standard tool is JSDoc. In Java land, the standard tool is JavaDoc. In PHP land, there's something called PHPDoc. Again, very similar languages. They all use the @ symbols and the tags. And it produces documentation which may be ugly, it may be weird looking, but it's consistent. It is the tool for the job, so use the tool for the job. Basically, I would always say when writing JavaScript, do things the JavaScript way. When writing PHP, do things the PHP way. And so we've made the decisions within our JavaScript experience that we're going to use one of the very popular libraries for interacting with the DOM, jQuery. There are others, so it's not that we had a choice of one, but jQuery is extremely popular, so it's a very good choice, and it's a choice I made for the series, so we're using jQuery. We needed some sort of test suite, and there were a few to choose from, but really, far and away, the winner in the category, in my mind, is QUnit, and the advantage of QUnit is it's made by the jQuery people, so there's a nice bit of synergy there. And then it comes to writing our documentation. Well, there's only one player in town, and that's JSDoc, so we're using jQuery, QUnit, and JSDoc. That's our tool chain, or that's our toolbox for JavaScript stuff, and so we do things in the JavaScripty way. Anyway, that's everything I wanted to show you and describe to you. I hope you found this kind of screencast interesting, and do please leave feedback and let me know how it went. Thank you very much. I've been Bart Bushots. You can find me at bartb.ie, and this is part of the Programming by Stealth series at bartb.ie/PBS.